All right, guys. So for those of you who were in our live meeting first block, I figured out what I was doing wrong on this problem. So when we read the problem, we have two squares. One is larger than the other. The large one has a side length of 3/4, and the small one has a side length of 1/8. And we want to know how many of these small squares will fit into here without any overlap occurring. So when I look at my fractions, I can see that I have two different denominators. And one thing that'll be helpful to solve this is to change this fraction of the larger square to where it has a common denominator with the small square. So I'm going to change this into eighths. So to change 3/4 to eighths, I have to multiply. And 4 times 2 is what's going to give me this 8 here. Now, to keep things proportional, I am going to multiply the numerator by 2 as well. So 3 times 2 is 6. So 3/4, I'm going to write in a different color, is the same as 6/8. So now that I've done that, it makes it a little bit easier to see how many squares are going to fit against each side length, because I can compare my numerators. This is 1 and this is 6. So what I would do to 1 here to turn it into 6 is multiply by 6. So along each side here, I can fit 6 small squares. And you may think, ooh, I'm done. My answer is 6. But that only fills up one little piece, one little of my larger triangle. So I need to go all the way up, because really this is 6/8 times 6/8. Every side is 6/8. So if I can do 6 across the bottom, I can also do 6 up the side. So 6 squares times 6 squares gives me 36 squares total that will fit. So my answer is D.